what we're going to use for the lecture is just my notes, which are the authorization lecture outline. So if you guys want to follow along on your own screens, there's a slide deck here, but I'm actually just, for this particular one, going to use my notes. So I've got that opened up here, and you're going to see given in tandem with Lab 0402. So this is really just to gear you guys up for this next lab assignment that's due this week. And so when we look at, kind of zooming in, the objectives for today, we're going to limit who can access the use our API endpoints. So you've seen that a little bit already. Last week, we made sure that users were logged in, that they were authenticated, but we're going to be able to apply all sorts of different permissions now. We're going to be able to get much more ingrained, fine detail on our different routes. Number 2, discuss different ways of modeling permissions in the database. And so just like in anything else in coding, there's a bunch of ways to do this. I'm going to have you guys implement one particular way. However, that doesn't mean that's the only way that you can deal with permissions in a database. We're going to talk about a couple, 2 to 3 different ways. We're going to write some middleware, or we're just going to bring in some middleware to make sure you are authorized to hit different routes. We're going to understand the usage of 401 and 403. Pretty simple. Everyone's very familiar with the 404 not found. Remember that the 400 category generally means an error with the client, right? 500 typically means an error with the server, right? 200 means it's okay, right? Generally just broad categories. And so we're going to kind of just, hit these more specific status codes. Because again, everyone knows 404, but 401 and 403, they apply to what we've been learning. And then prevent users from editing data they do not own. And if you think about so many cases, any social media, right? You can make a post, and maybe you have the ability to edit your own post. On Discord, you can send a message, and maybe you can edit your own message. But because you can edit your own message, that doesn't mean that you can edit anyone else's message. That doesn't mean you can edit anyone else's post. So this is all about permissions. This is all about users, giving users permissions, putting users in groups. And that is defining authorization. So it kind of helps to start with definitions. And you can read these as well as I can. But authentication is proving your identity. That's what we did last week. We talked about all the different ways you can authenticate to a system. Most of the time nowadays, it's just username and password, or email and password, right? And that's what we kind of talked about last week. Getting your websites to enable authentication. Very specifically after you authorize yourself and you prove your identity, right? Then what is authorization? Authorization is a process of determining if you have permission to perform an action, like any CRUD action, right? Update something, delete something, create something. Or, also a CRUD action, view some data. And so what we're going to find out is that we have all these endpoints on our APIs to perform different actions. And all of our endpoints can implement authorization differently. And so that's the direction we're heading. We're going to wind up with different roles and different permissions that different roles have, and then putting permissions, for those roles on the endpoints. Again, it does imply that you must be authenticated first. Okay, you must be authenticated before you can be authorized. You cannot give somebody permission without first knowing who they are, right? So that's why we take care of authentication first. And once we got some good authentication going on, then we can authorize them. And so kind of a different definition, a little bit more detailed from this tech target. Authorization is a process of giving someone permission to do or have something. If you've ever taken a Windows course like Windows 10 or Windows Server, you deal with permissions a lot, and putting permissions on groups to either allow someone to do something or deny someone to do something. And so you kind of have to look at it from both of those aspects, either allowing someone to do something or denying them. And again, we can read this. In a multi-user computer system, a system administrator defines for the system which users are allowed to access the system and what privileges of use, such as access to which file directories, hours of access, amount of allocated storage space. And so again, I always relate this back to what I know of like Windows system admin. Before I was a developer, I worked at a help desk, and we had to do these kinds of things. We had to set users to allow them to do certain things or deny them to do certain things, to give a user so much hard drive space, so much storage space on the shared drive. Same thing with your email systems, right? Email systems have quotas and how many megabytes or gigabytes of storage that you can store in the email system. And so it's rules, right? You're just assigning rules and permissions to your users. Assuming that someone has logged into a computer operating system, so again, you're authenticating first. The system application may want to identify what resources the user can be given during the session. Thus, authorization is sometimes seen as both the preliminary setting up of permissions by a system admin and the actual checking of permission values that have been set up when a user is getting access. And so the normal workflow, is every business works a little bit differently. And so when it comes to what groups are there and what can those groups both do and what can they not do, that's kind of set up by, meetings. You're going to sit down with different, what are called stakeholders in the business, and you're going to basically sit down with the rules, with the administrators, and they're going to tell you what people can do in their system and what they can't do in their system. Okay, so when it comes to different applications, different pieces of software, so in the classroom, we're talking about like inside ranking, right? So inside ranking, what can the users do and what can the users not do? So granting permission. So only students that are part of a course can view the assignments. I mean, you guys can see your assignments. Of course, you can't see the assignments of an automotive student. You're not enrolled in the course, right? So that's allowing access to do something. Only students that are part of a course can submit work for those assignments. Makes sense? You can only view those assignments, and you can only, update those assignments or submit work for those assignments. Students can only turn in work for themselves, not other students. Again, just setting up some things that you can do. Only teachers can create, edit, or delete assignments, right? So, of course, I can do some things you can't do. You can do some things I can't do. I can't submit work for you, right? You have to submit work for yourself. So we have different permissions. Teachers can view all the assignments. Teachers cannot submit student work. Teachers can grade assignments. And of course, teachers cannot grade assignments for other courses. And so these are all sorts of permissions about things that this is a system that we're familiar with, a website that we're familiar with. We log in first, and then based on our roles, and the things that we belong to, we can do things and not do other things. So in another kind of e-commerce store, right? Anybody can browse a catalog without creating an account. Thinking about Amazon, you can look at the products. In order to place an order, you got to create an account. To view your past orders, you need an account or an email. But yeah, probably going to set up an account. Might have something called a catalog manager to edit the products, to edit the catalog. What can you sell? Catalog managers can add or remove items. Catalog managers can edit product names, descriptions, and prices. Warehouse stockers basically can, box up items and ship orders. So warehouse employees, if you will, stockers. Managers can run reports on what has been sold and shipped. Managers can run reports on stock levels, right? Order more of something, order less of something. Managers can run reports on customers. Managers can run promotional campaigns. Developers can run reports on what browsers, operating system, devices your customers are using, right? So different software, different permissions. That's all we're kind of getting into. Kind of looking at a social media. So pick it, Twitter, X, Facebook, Instagram, whatever social media of your choice. Anybody can create an account. Users can edit their own profile. Users can make posts, comments, or upload photos. You cannot edit anybody else's profile. Nobody can make a post or comment impersonating another user. Nobody can edit another user's post or comments. And you might have moderators. Moderators can disable or delete offensive accounts. Moderators can remove offensive post comments. Although you might update the word offensive to what violates the terms of service, right? Just because someone finds it offensive, well,
doesn't mean that it is.
Doesn't, yeah, that's right. Right, so nonetheless, so now we start thinking about permissions for our issue tracker, right? And so the question becomes, how does this fit in with our issue tracker? And you guys may remember we have a bunch of rules that we kind of glossed over from a prior assignment. And what assignment was that on where we had all that list of rules? I see Matt has it pulled up.
The original, the issue tracker project. It's on the main page.
So on the main page, if we scroll up, right here, on 4, AWD 1111 issue tracker project. You guys might remember this page. And I kind of like jazz hands over this, like, hey, we'll worry about that later. Don't worry about that now. We'll worry about that later.
Well, now it's later.
Now is later. Now is later. So we have a bunch of rules that, any user can edit the bugs they create. Bugs can be assigned to certain roles, right? Now, I didn't make up this language. I would think you would call these groups. Developers is a group, business analyst is a group, quality analyst is a group, but it's just a synonym for roles. So when I say role, it's just another word for a group of people. And so business analyst is a group, quality analyst is a group, developers is a group, or more commonly you're going to hear it called a role. So this is going to be something that we come back to. Business analysts can classify bugs. Quality analysts can add test case. Developers can track the amount of time they spent on a bug. Developers can note what version of the software made a fix and when the fix was applied to the code. Business analysts can close bugs. Okay, so these roles that kind of come back here, they're coming back in this lab, in this 402. In fact, well, we'll get there. If you open up 0402, you'll see it. So the question there is, how does this fit in with our issue tracker? And it's like, well, these permissions have already been laid out pretty well for us, and now we just got to bring this into our API backend. Okay, database modeling. So how do we bring in these permissions and these roles into our database? And the first way you could do this is with Boolean flags right on the user document. And so what is a flag? A Boolean flag is just a true or false. And so you could put a Boolean is admin, Boolean is moderator, true or false. And then you could write if is admin, welcome to the route, kind of thing. If you don't have the flag, else you don't have the flag, get out of the route. You're not allowed. And so the most simplistic way of bringing this in, you just throw Boolean flags on this. Truth be told, I've never modeled something this way because this is not considered scalable. This is not considered like very friendly for code reuse. This is something that would require a lot of if-else statements, and for smaller websites, for small applications, totally a feasible option. But I would say it's not very scalable, and it's a little bit, the code isn't replicatable very easily, right? You're gonna have to rewrite a lot of code. So I don't love this option, so I've never coded it. But it is an option, okay? That's not to say that if you have just want to put something simple for some basic permissions, this is simple, right? Just have Boolean flags. I was taught early on that even if you have a single user with a unique set of permissions, you put that user in a group and you assign the permissions to the group. So that's something that I was taught in the industry early on. Even if you have a single use case for one user, you put that user in a group, and then you assign the permissions to the group. That way, if and when there's a second user that needs those same permissions, you just put that user in the group and they inherit all the permissions.
Scalability.
Yeah, it's scalable, right? So then we're probably not going to be using Boolean flags, although it's an option. So we are going to be using roles. Again, roles is a synonym for groups. Roles allow for permissions to easily be assigned to groups of users. They also make it easier to extend the system with additional roles later. Yes?
So I actually use them together. I use the roles and then I did the switches based off which role they have.
And that's fine. That's fine. You could use a combination of both roles and Boolean flags.
Because if that has permissions, it was
Yeah. Yeah. And you might see, I might code it a little bit differently, but again, there's always multiple potential solutions. You could use these in combination. So when it comes to roles, again, now we're grouping of the users. The role is stored as a string on the user document. So if I look at a single role, now, I don't know if I'm using Discord as my example, I can add you guys to many roles, right? You could be the student's role. You could be there's a group for tutors, so you could be both a student and a tutor. and those might have different permissions, right? And so even in that example, right, you're looking at a single role. If a user can only have one role, or can your users have many roles? Okay, well, it's pretty simple. If it's a single role, the role is a string, right? So in this case, the role attribute on our user document is a string, and in some applications that may be the case. Your users may only belong to one role. Or can your users have multiple roles? Now, in the case of Bug Tracker, it is definitely the case that you could be a developer and an administrator. So it is the case that we will implement multi-roles. So our role here will be an array. And I'm pretty sure it was a refactor last week. Some of you called me over and you said, hey, Mr. G, I see this role and I see it's an array, but it was just a string before. Why is that? Right? I got that question several times last week. And the answer is, well, that allows us to have multiple roles, each role having its own set unique permissions.
And that's kind of where I was going. So, like,
yeah.
You can be a developer and a business analyst.
Yeah. Yeah.
So you can close bugs and not
And
close bugs.
Well, so
That's the only confusion, or at least for me.
yeah. So the general rule of thumb there is if you have a deny and an allow, the deny takes precedence. Okay, so if one role allows you to do something and another one denies it, the safe behavior is to deny.
Okay.
That's right.
That's why the Boolean is important, right? Because if you do the Boolean, then once you find it true, it's going to execute anyway. I don't think that denial will take precedence if you do if it's true, if one of these is true, you do it anyway.
It could go either way. I could see it going either way. Okay, so again, the role on a single role, it's stored as a string. In this case, which is the case that we're going, and that your roles is an array, and you're in different groups, and each group has a different set of permissions. Okay, what you're going to do is you're going to wind up combining those permissions together for kind of the resulting permissions. Right, which is kind of where we're going, and it's like, hey, either you're allowing to do all these things or you're denying these things. You're going to have to combine them all together somehow. So there's going to be some looping over the roles and then putting all the permissions together. So that's just where we're going. So that's a little bit of a foreshadow there. Each role has a fixed set of capabilities. Again, we're talking about permissions here, which are documented in the requirements. I showed you where to get those. If a user has a role, they receive all the permissions for that role, of course. Some systems only allow users to have one role. Others allow users to have multiple roles. Of course, we just said we'll have an array of roles. If they have two roles, then they are authorized to perform all the tasks of both roles. Okay. So roles are your groups, and then you assign the permissions to the groups. So now we need to get into actually looking at, this is how you model in the database. This is how you model the groups. How do you model the permissions? And so one option, again, I'll preface it with I don't love this option, is that each user could have their own set of permissions, and that's unique to the user. Why don't I like that? Again, I already said, even if you got a single user with their own permissions, you should put them in a group. Like, that's what I was taught. I do believe that's the most scalable, viable option. But you could. So what do we have here? We have a permissions property, and it's a JSON, JavaScript, JSON object with a bunch of Boolean fields: can edit profile, can change email. All of these, what you can do, just It's whatever you need it to do. It's completely customizable, whatever your system needs. And again, this might be overkill, right? This might be overkill for what we need, but it is very fine-grained, right? It is in the weeds. It is as specific as you can get, like down to the individual permission, what people can and cannot do. But it's a little more complex to implement and manage, right? I don't find it super complex. We will do it. I think you'll agree with me after doing it once or twice. Not so bad. Auditing permissions can be more difficult, and I think that's what Henry was saying a little bit earlier. And it's like, hey, you've got 4 permissions, and this one says yes, and this one says no. Why then is Billy able to do this? He shouldn't be able to do this. You know, like troubleshooting actual, like I think this is what should happen, but that's not what's happening. So we got to figure out why this is happening this way. So you got to track it. You have to audit it. You have to audit the permissions, find out why users are able to do what they're able to do, troubleshooting those kinds of problems. Yeah.
I think above, I think it said, before we got to the fine grain, I think the last sentence, it was saying there's like, if a user has 2 rows, then they just do both of those.
Correct. If they're allowed. If they're allowed. Right? But if one of them's deny, I mean, it's in my opinion, if you get the same thing, can do this and can't do this, I think it should default to you can't. Yeah. And maybe there's some override. Like if you really need that user to do it, maybe you should, figure that out. But the point is, if there's it's safer. Right.
So when the admin can go in and change somebody else's account,
Mm-hmm.
that's when I said if the admin changes anybody's account to the, because they can assign it on role.
Mm-hmm.
So once they do the role to product manager or other person manager, then give them the permissions. And that's how I gave each one of my users a permission.
Yeah, I'll have to take a closer look, but that sounds like that worked for you. So that's good. And here I am kind of bad-mouthing this approach, but, it's not to say that this isn't a usable system. This is going to be the direction that we head, that I'm going to recommend. Where your users have an array of roles, and then you have a role table, or collection as they're called in Mongo, and the individual name of the role might be quality analyst, and then what can quality analysts do in the permissions object. Okay, so the user has, and I can kind of show this off in a prior code base that I had. So here's my user system, right? Here's all my users. And if I look at any one user, I have an array of roles. And so here I am. And my first role is customer, then I'm a developer, and then I'm a quality analyst. So these are my 3 roles. It's an array of strings. And then if I go into the role collection, here's developer, here's quality analyst, here's customer. And if I look at the permissions, a developer can do these things. A quality analyst can do this one thing, and a customer can can do these other things. Now, I'm only dealing with the positive side, with what you can do, but you can also have more on the negative side, what you can't do, right? But by only focusing on what you can do, it's kind of on the other side of the coin. You just know what you can't do. If you're not allowed to do it, then you're not allowed to do it. So I think you can go either way. You can say, hey, only positives, and therefore implicitly you know what you can't do. Or if you want to be explicit, you can do both sides of the coin. You could say what you can do, and you can also say what you can't do. Okay? But this is going to be what I recommend that you use, is an array of strings on the user side, and then a role table with the permissions on what they can do, this is the modeling of that. Again, this is all you're seeing here is the name is a string data type. Again, that's like the name of customer. That's the role name. It says this system combines all the functionality of both roles and fine-grained permissions. Allows for all the customization of fine-grained permissions, but reduces complexity for administrators. This system is the most complex to get started with and to implement, but again, I find it to be the most scalable and flexible. But in the long run, it drastically reduces the complexity of permission checks within your routes. The point is you got a new user, you just put their roles on the user document, and they automatically inherit whatever permissions are associated with those roles. So overall, it tends to actually be the simplest. Each user can have 0 or more roles when they are stored in an array. Each role is represented as a role document within the roles collection. Each role has a configurable set of permissions. Roles can be added and removed as needed. And permissions can be added and removed as needed. And so you see this set of permissions and roles in all sorts of software. And, not to hit on this isn't certainly all of them, but PHP, I think Bulletin Board, WordPress. For any of you WordPress developers out there, you've probably seen roles and permissions. Drupal. The one I'm certainly most familiar with is within Windows administration. Windows has groups and permissions, as well as combining those things in what are called access control lists, ACLs, which say who can do what. So here you can click on and see who can do what as far as the groups are concerned or the individual users. Linux has a similar setup. MySQL. MongoDB itself. You can grant permission at the organization layer, the project layer, the database layer, the collection layer. So you could put permissions on all sorts of different entities in MongoDB. Discord is the one that I was referencing because that's what we use quite often in class. So here your instructors can do different things and the students can do different things and the alumni can do. Anybody ever use Mumble?
I have.
Back before the Discord
base.
Yeah. GitHub.
Ventrilo.
Yeah, Vent, I think they called it.
Yeah.
Okay, so that's the general setup. So now how do we implement it? Now that we have seen how the system works in a number of popular applications, let's look at how we can implement them. First, we have to authenticate, and then we authorize. They are commonly implemented by using a series of middleware functions. And so the request comes in from the user. Number one, hit the authentication middleware, right? Make sure they're logged in. And we did this last week, right? I remember walking through logging in the user, and then when the user is logged in, it sets the rec.auth. So the request object does not have an auth property by default. But we put it through some middleware functions that created a request property that says, hey, once that user is logged in, created an auth property. If the user tries to hit a route, but they're not logged in, that authorization middleware can send a 401. And 401 simply, you're not logged in, right? So again, just going back to those error codes, 401 response means you're not authenticated. 403 means you don't have permissions. You're not authorized. You're not granted access. So 401, you're not logged in. 403, you don't have permissions. So that's the difference between those two status codes. And that could be done at the middleware level. And then after that, your route handler, if you actually can get into the route, you can also send a 403 if the user does not own the data, right? So we talked about a little bit earlier, like you can't edit someone else's post. And so if you're not the owner of the data, you can write, it doesn't have to be done at the middleware level. I'm just kind of suggesting here that this could actually happen in the route, that if you're not the owner of the data, you could also send a 403 back once you're actually in the route. You could write middleware to do this as well. But I think it makes a little bit more sense to write it at the route level. That way you could see, if the data you're working with is in fact yours, if you're the owner of that data. Like I'm thinking about like a bug has a comment, and if you were going to edit that comment, did you make that comment? Are you the user ID of the user who created that comment? And in order to kind of test that, you would do that at the route level. So again, this is suggesting to do some different things in some different places. All right, so here, notice the authentication authorization process happens in multiple stages. First, we must process the credentials, typically with our JWT token, and verify that they're valid. Again, all that token is saying that you've previously logged in, right? Anytime you see this JWT token, like take that away, that's the takeaway, is that the user has previously logged in. If the user is not logged in, you send a 401 and you're done. If they are logged in, if they have that token, then you want to see if they have the right roles or permissions. And if they don't, you send a 403. So number one, log in, send a 401 if you're not. Check the permissions. If you don't have permissions, you send a 403. Then you actually hit the route. When you hit the route, then you could start to actually hit the database, right? Hey, this user is trying to edit the comment. This comment has a user ID for the user who created the comment. Is the user who's trying to edit this comment the same user, right? You do that at the route level. You have to actually have a database query. Because you have to do that at a database query, you want to do that at the route. You're not really doing that at a middleware level. So if the user owns the data, if not, send a 403 back and stop there. And then only if you've passed all the above hurdles do we proceed with the request. So that's the workflow. Last week we got basically down to the point where it was a 401. And if you weren't logged in, it was throwing an exception, right? And I showed you guys how to catch those uncaught exceptions. It says, note that some routes will allow anonymous access. We saw that a little bit, right? In order to register an account or to log in, you don't need to do some of those steps. The permissions are wide open. So any role can access, meaning you don't need to check for the roles or permissions. So sometimes you can skip that. Sometimes they're wide open, meaning, only 2 or 3 roles will access them, or sometimes they're wide open and you can skip. So again, basically what this boils down to is different routes. Almost all of our routes will have a different kind of process that they follow to either grant access or deny access to those routes. Will allow any user to view or edit any record, not just data they own. So again, it just boils down to every route is different and will need a different set of permissions. It says, notice that the pipeline above splits this process over 3 different parts to encourage code reuse. The auth middleware only verifies the token, but does not reject any requests. The auth middleware checks both that the user is logged in and that they have the appropriate permissions. And then the route handler performs any ownership checks that are required. Again, because you gotta hit the database in order to do that. And so we kind of looked at the isLoggedIn function, very similar to this. isLoggedIn at a high level just says, hey, if there's no auth property, then send back a 401. You're not logged in. There's a function has any role. If you're, if your auth doesn't have a role, it says you have not been assigned a role, right? So if there's no rec auth, you're not logged in. Otherwise, 403, you have not been assigned a role if your role hasn't been assigned. I think it might be a little bit more beneficial to look at it from the middleware standpoint, but these are just some old notes. And these are functions that we will have the ability to use. We'll use different functions at different points in this class. So again, has any role is a function, has a specific role. There's also has permission. A lot of this stuff has been a little bit updated, so it might be a little dated as we get down here towards the end of the notes. Has permission. So again, because users can have multiple roles, you might just want to lock down a route to a very specific permission. So you can call this middleware has permission to look for a very specific string, like can edit post kind of thing. And here's an example of making sure that you're the owner of some data, right? Again, this is actually done in the route handler. So yes, you are checking that a user is logged in, but then we actually have some logic to check out your ID of the logged in user and to see if that ID matches the ID of what's stored in the database. Right, so rec.auth could potentially have a user ID of the logged in user stored in the database, right? So that's coming from who you are as you've logged in, and then you're checking that against the database. And if you're not, right, you'll get an error message back, you are not the author of the post. And that should actually be 403. Here's an example of using a middleware called has permission, where you're looking for one of those very specific permissions, like you can edit a post. Again, those permissions will be defined probably on paper first. You define the permissions on paper first, and then you put them into your database, and then you can use middleware to check to see if a individual user has that individual permission. All right, so really the next step that you could do is we need to begin to start thinking about, in a table format, what are our different groups, and the groups would go across the top: developer, administrator, quality analyst, and then the permissions on the row side, right? So the columns are our groups, and then the permissions would be the rows, and then making a checklist of what each different group can or cannot do. Again, following this kind of format. I think that's just a joke. Step 7 is profit. Isn't skip to that one? Just skip to the start making money. Isn't there like a South Park episode or something? It's like 3 steps. Anyway, there's a South Park joke in there somewhere. Moving forward. So when you're writing out a list of permissions, figure out, write down all the entities in the system, all the groups, all the actions that can be taken, and then give each action a distinct permission. Okay? So now, what I'm going to encourage you guys to do is take our requirements and begin to build a little chart like this, and you can open them up on Excel. You can work as an individual, you can work in a group. But this is what I would like you guys to do a little bit today, just as part of the exercise of figuring out what are our groups and what are our permissions. Make a chart similar to this, and that will kind of prepare us for tomorrow. Okay, as far as what the users can and can't do. And that's the quick intro to authorization. I know I didn't spend 4 hours on it. I don't know if that makes you happy or sad, but just give that brief introduction.